Hello learners, in this lecture we are going to learn about rank correlation. In calculating the Pearson's correlation coefficient, it is necessary that the data should be definitely measured. Sometimes exact magnitude of data cannot be determined, but they can be ranked according to some criteria. For example, a teacher may want to know how far a boy's ability in sports can determine his popularity. But it is extremely difficult to give a numerical value either of these qualities. However, it is easy to place the boys in order for each of these qualities and to measure the association between the two ranking. Sometimes one variable may be in ordinal measure and the other is in either ratio or interval data. When the data are not available in the form of numerical measures, but it is possible to assign ranks to the data, then non-parametric procedures can be applied in correlation analysis. When two variables can be ranked separately in ordered series, it is possible to compute a rank correlation coefficient. This rank correlation coefficient is a measure of the degree of association between two sets of ranks. Different types of rank coefficients can be applied to the data. Spearman rank order correlation coefficient is the most widely used measure of rank correlation. Before discussing Spearman rank order correlation coefficient, we may summarize some of the situations when rank correlation method is applicable. Rank correlation is applicable to find the strength or degree of association of data that are expressed in ranks or scores. That is, the data is expressed in ordered series. Rank correlation allows us to correlate between two sets of qualitative observations which can be ranked or ordered. Rank correlation can be used as an alternative in finding the degree of association for two sets of data originally given in measurements. Rank correlation can be useful where there are extreme observations in the original numerical valued data. Now, what is Spearman's rank correlation? Spearman's rank correlation is the non-parametric version of the Pearson product moment correlation. When the assumptions of the Pearson correlation is violated, then Spearman's correlation can be used. Spearman's correlation coefficient measures the strength and direction of association between two ranked variables. Spearman's rank correlation does not carry any assumptions about the distribution of the data and is the appropriate correlation analysis when the variables are measured on an ordinal scale of measurement. Spearman rank correlation was developed by Charles Edward Spearman in 1904. Now look at the assumptions of Spearman's rank correlation. The measurement scale is at least ordinal. There are two variables. The scores in one variable must be monotonically related with the other variable. Each criteria under study is ranked separately on each variable. Before using Spearman rank correlation coefficient, we have to see whether these requirements are fulfilled or not. Spearman's rank correlation method is particularly suitable to the situations where the data values are less than or equal to 30. Now look at the formula and interpretation of Spearman's rank correlation. Spearman rank correlation coefficient is equivalent to Pearson correlation coefficient on ranks. Spearman rank correlation coefficient can also be computed by using the following formula here. You can see here RS equal to 1 minus 6 into summation of di square, where I varies from 1 to n, divided by n into n square minus 1, where Rs is the Spearman rank correlation coefficient D is the difference between the ranks for each pair, and N is the number of paired observations. Now, how can we interpret Spearman's rank correlation coefficient? The Spearman's rank correlation coefficient can be interpreted in the same way as Karl-Pearson coefficient